Chapter 4, Quadratic Equations. The first question, find the discriminant of the following quadratic equations. If the real roots exist, find them. So we are having totally 3 bits in this. The first one, 2x square minus 3x plus 5 is equal to 0. So the solution for this, from this equation we have a is equal to 2, b is equal to minus 3, c is equal to 5. So now the discriminant, which is denoted as capital D, is equal to b square minus 4ac. So we have to check whether it is equal to 0, greater than 0 or less than 0. So what kind of roots does it have? By seeing this we can do. So minus 3 whole square minus 4 into a is 2, c is 5. So you're getting a 9 minus 40, which is equal to minus 31. Therefore d is less than 0. Therefore, since d is less than 0, therefore we have the given quadratic equation has no real roots. The given quadratic equation has no real roots. So if we are having roots only, we are going to find out real roots, otherwise we are not finding it out. For the second one now, second equation is 3x squared minus 4 root 3x plus 4 is equal to 0. Here you have a is equal to 3, b is equal to minus 4 root 3, c is equal to 4. So now putting all these values in the discriminant, d is equal to b square minus 4ac, which is equal to minus 4 root 3 whole square minus 4 into 3 into 4. So which is equal to 16 into 3 is 48 minus 16 into 3 is again 48. So you're getting here this is equal to 0. Therefore d is equal to 0. Therefore the given quadratic equation if d is equal to 0, they have equal roots, has equal roots. Now what are those roots? We'll just see. So x is equal to minus b plus or minus root d by 2a, which is equal to minus of minus 4 root 3 plus or minus root of 0 divided by 2 into 3. So which is equal to 4 root 3 by 6, which is equal to 2 root 3 by 3, which is equal to 2 by root 3. Hence roots are 2 by root 3 and 2 by root 3. Third one, you have 2x square minus 6x plus 3 is equal to 0. In this a is equal to 2, b is equal to minus 6, c is equal to 3. So therefore the discriminant d is equal to b square minus 4ac, which is equal to minus 6 whole square minus 4 into 2 into 3, which is equal to 36 minus 24, which is equal to 12. Since d is greater than 0, therefore the given quadratic equation has real and distinct roots. So it has here two different roots. So what are the roots? We'll just see. X is equal to minus b plus or minus root d by 2a, which is equal to minus 6 plus or minus root of 12 divided by 2 into 2, which is equal to minus 6. It is minus of minus 6 because minus b, isn't it? So it becomes 6 plus or minus 2 root 3 by 4, which is equal to 3 plus or minus root 3 by 2. So you're having the two roots which we have here are 3 plus root 3 by 2 and 3 minus root 3 by 2. So these are the two roots which you are having. Now going to the second problem, find the values of k for each of the following quadratic equations. Find the values of k for each of the following quadratic equations so that they have equal roots. So first one in this is 2x square plus kx plus 3 is equal to 1. So when do the quadratic equation have equal roots? When the discriminant is equal to 0. So solution for this is, what is a? A is equal to 2, b is equal to k, and c is equal to 3. C is 3. 2 into 3, which is equal to k square minus 4 3s are 12 minus 12 into 2 is 24. So for equal roots, what is the condition? For equal roots, the quadratic equation has equal roots means the discriminant should be equal to 0, which implies that k square minus 24 is equal to 0, which implies k is equal to plus or minus root of 24. So therefore here you are getting it as, or you can, if you want, you can write one more step here. This is the step. So which implies this is the answer, which implies that k is equal to plus or minus under root of 6 into 4, which is equal to plus or minus 2 root 6. So what's the second one? We'll see now. We have k x into x minus 2 plus 6 is equal to 0, or this can be written as kx square minus 2kx plus 6 is equal to 0. So what is a? A is equal to k, b is equal to minus 2k, c is equal to 6. So therefore now you are having capital D, that is the discriminant is equal to b square minus 4ac, which implies that minus 2k whole square minus 4 into k into 6, so which is 4k square minus 24k. So now since it has equal roots, the quadratic equation, so for equal roots the condition is, for equal roots the discriminant is equal to 0, which implies that you are getting here 4k square minus 24k is equal to 0, which implies that you can take out 4k common, you will get it as k minus 6 is equal to 0. So from this you can write 4k is equal to 0, or k is equal to k minus 6 is equal to 0. K is equal to 0 and k is equal to 6. So therefore these are the answers for k when the given quadratic equation have equal roots. What is question 3? We'll see. Is it possible to design a rectangular mango grove whose length is twice its breadth and the area is 800 meters square. If so, find its length and breadth. So now for solution for this, let the breadth of the rectangular mango grove be x meters. So length is equal to 2x meters. So according to the question, we have area is equal to 800, which implies that length into breadth is equal to 800, which implies that x into 2x is equal to 800, which implies 2x square is equal to 800. Or you're having x square is equal to 800 by 2, which is equal to 400, or x is equal to x square minus 400 is equal to 0. You can write this equation as x square plus 0 into x minus 400 is equal to 0. So a is equal to, it is in the form of ax square plus bx plus c. A is equal to 1, b is equal to 0, c is equal to minus 400. Therefore, the discriminant is equal to b square minus 4ac, which is equal to 0 minus 4 into 1 into minus 400, which is equal to 1600. So the given quadratic equation has real roots. So the given quadratic equation has real roots since d is greater than 0, and hence it is possible to design a rectangular mango grove. Now solving the quadratic equation. Using the quadratic formula, we have x is equal to minus b plus or minus under root of b square minus 4ac divided by 2a. So you are having b as 0 over here, plus or minus root of 1600 divided by 2 into 1, which is equal to minus 0 plus or minus 40 divided by 2, which is equal to 20, or 20 and minus 20. X is equal to minus 20 is not possible since the length cannot be negative. Therefore x is equal to 20. So x is equal to 20. Hence breadth of the rectangular mango grove is 20 meters and length is equal to 2x, which is equal to 2 into 20, which is 40 meters. Now going into the fourth one, Is the following situation possible? Is the following situation possible? If so, determine their present ages. So we have the sum of the ages of two friends is 20 years. 4 years ago, the product of their ages in years was 48. So what's the solution? We'll see. Let the present age of first friend be X years. The present age of the second friend is equal to 20 minus X. So 4 years ago means previously. What is the age of first friend? Is equal to X minus 4 years. Age of second friend is 20 minus X minus 4 years, which is equal to 16 minus X years. According to the question, we have X minus 4 into 16 minus X is equal to 48, which implies that X minus X square minus 64 plus 4X is equal to 48, which implies that minus X square plus 20X minus 112 is equal to 0, which implies if you multiply throughout by minus sign, you're getting X square minus 20X plus 112 is equal to 0. Here A is equal to 1, it's in the form of a quadratic equation. So A is equal to 1, B is equal to minus 20, C is equal to 112. So now we'll find out what is the discriminant. Now D is equal to B square minus 4AC, which is equal to minus of minus 20 whole square minus 4 into 1 into 112. So you're going to get it as 400 minus 448, which is equal to minus 48. Since discriminant is less than 0, so the given quadratic equation has no real roots, and hence it is not possible to calculate the present ages. Now going into the next problem, the fifth one. Is it possible to design a rectangular park of perimeter 80 meters and area 400 meters square? If so, find its length. If so, find its length. So now what is the solution we have? let the length of the rectangular park be x meters and breadth be y meters. According to the question, perimeter is equal to 80 meters, which implies that 2 into L plus B is equal to 80 meters, which implies 2 into x plus y is equal to 80, which implies that x plus y is equal to 40. So which implies that y is equal to 40 minus x. Therefore breadth is equal to y, which is equal to 40 minus x meters. Now area is equal to 400. So length into breadth is equal to 400, which implies that x into 40 minus x is equal to 400. 40x minus x square is equal to 400, or which implies that x square minus 40x plus 400 is equal to 0. So here you are having a is equal to 1, b is equal to minus 40, c is equal to 400. Therefore our discriminant d is equal to b square minus 4ac, which is equal to minus 40 whole square minus 4 into 1 into 400, which is equal to 1600 minus 1600, which is equal to 0. So our discriminant is equal to 0. So the given quadratic equation has equal roots, and hence it is possible to design a rectangular park now solving the quadratic equation. X square minus 40x plus 400 is equal to 0 by quadratic formula. We get x is equal to minus b plus or minus root of d divided by 2a, which is equal to minus of minus 40 plus or minus root 0 divided by 2 into 1, which is equal to 40 by 2, which is equal to 20. Hence length of the rectangular park x is equal to 20 meters and breadth is equal to 40 minus x meters, which is equal to 40 minus 20 meters, which is equal to 20 meters.